Hello, 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 amazing students. Today I am hoping that I can go over the first page. Just a quick recap of the first page. Complete this problem and then do all of the problems that are on the back so that this can help you as a study tool for the quiz. Remember, this worksheet that's also in Google Classroom has an answer key, and it also has YouTube links that you can click on. Of course, you can't click on these, but the PDF has a link that you can click on for each section that might be of extra help. So for number 1 through 6, just remember that you're dealing with imaginary numbers. If you're adding imaginary numbers, it's like adding 7 plus 4 igloos plus 3. What's 7 plus 4 igloos plus 3? You can only add 7 plus 3. The 4 igloos is a variable. You can't add 7 plus 4i, but you can add 7 plus 3. So addition is very much like any algebra you've done in the past. But when it comes to imaginary numbers, there's 2 rules that you need to focus on. I is when you're taking the square root of -1. And the second rule is if you ever square I, you're going to get -1. So this rule is very important, as you never want to leave your answer as I squared. For example, on number 4, when you multiplied I, or -I, and 3i, when you multiplied that using an area model, you should get -3i squared. But what is I squared, right? I squared is -1. Here's the reason why. If you ever square -1, you're going to get -1. So for this equation, we have to continue simplifying, and we're going to get -3 times -1, which is 3. So when you multiply just this and this, only those 2 parts, you're going to get 3. Keep that in mind when you're checking your work. For number 7, there is the 3, 4, 5 Pythagorean triple, meaning 3 squared plus 4 squared equals 5 squared. There's 5, 12, 13, meaning 5 squared plus 12 squared equals 13 squared. There's 7, 24, 5. I also missed one. It's 8, 40, 41, but I wrote it on the board. It's just, these ones are a lot less rare than these. These 2 are the ones that you really need to focus on for the quiz and the future. Number 8 through 9, of course, we talked about building the triangle. If you know what cosine is, then you can find out what sine and tangent is. If you know what tangent is, then you can build the triangle and find out what sine and cosine is. We did a review of special right triangles and the steps that it took to get to your answer. So I just wanted to finish off letter B following these same steps, as letter B does include some more difficult steps. So let's follow the steps here. Step 1, label your 30, 60, 90s, or if you have a 45, 45, 90, label it this way. What I'm going to do is I'm going to start off with the 30, 60, 90. You notice how the 30, 60, 90 gives us a side of 4, but the 45, 45, 90, which is also here, doesn't give us any side length. So I'm going to start by labeling the angle 30, since it's a 30, 60, 90. And I'm also going to label this one a 45, since that's 45. Let's start with the 30, 60, 90. According to step 1, we're supposed to label each side 1, √3, and 2. So across from the 30, I should label it as a 1. Across from the 60, I should label it as a √3. And the hypotenuse, I should label it as a 2. Know that these are not the answers. That's why I'm writing them very small. This is the answers. It's a step to get to your answer. Okay. Step 2, let's find the scale factor by division. Well, where do we have a pair of numbers that we can compare? 4 compared to 1. Scale factor for this one is going to be 4 over 1, which is, of course, 4. We found the scale factor for the 30, 60, 90. Now our last step is to multiply the scale factor. It says to multiply the scale factor to get our missing sides. So 4 times root 3 is 4 root 3. 4 times 2 is going to be 8. This is the answer for that hypotenuse. Remember, this hypotenuse is actually the hypotenuse for this triangle. It's also the hypotenuse for this triangle. So now that we solved the 30, 60, 90 using these 3 steps, we're going to follow these same 3 steps for the 45, 45, 90. Step 1, let's take a look at this 45, 45, 90. How do we label a 45, 45, 90? Right? We label it with a 1, 1 root 2. So 1, 1, and you can forget this stuff now. Divide the 8 by a root 2. So step 1, label. Step 2, find the scale factor. The scale factor is going to be 8 divided by root 2. Well, we know that if we have like 10 divided by root 2, we have to rationalize the denominator, so this one we have to do the same. We're going to multiply by whatever is in the denominator. So root 2 over root 2, which gives us 8 root 2 over 2. 8 root 2 on the top, and when you multiply those two values, root 2 times root 2, you're going to get 2. Now 8 over 2, that's going to be 4. So 4 root 2 is our scale factor. Scale factor is 4 root 2. Okay, now that we found the scale factor, we have to multiply that by the scale factor to get our missing values. So 4 root 2 times 1, we know that's going to be 4 root 2 for that side right there. I know it's messy, I'm sorry about that. And then 4 root 2 times 1 over here is going to give us 2 answers of 4 root 2. Now a little bit of a trick for those of you who are sticking around for the video, you're going to get a little bit of a trick now. Here's the trick. If this is an even number for a 45, 45, 90, let's say it's like 30. Well, what happened here? When it was 8, the other sides were 4 root 2. When it's 30, this is going to be 15 root 2. What about when it's 12? What would this be? Yeah, I cut it in half and multiply by root 2, so 6 root 2 over 6 root 2. Of course, you want to show your work for that. If you divide 12 by root 2, you're going to get your answer. So let's show the work. 12 root 2 over 2. What's that give us, right? 12 over 2 is 6, 6 root 2. The pattern is always going to be half. Like, look, when we did 8 divided by root 2, we got 4 root 2. 12 divided by root 2, we got 6 root 2. 30 divided by root 2, we're going to get 15 root 2. So what if I had a triangle, a 45, 45, that had a hypotenuse of 100? What would these be? Right? They would be 50 root 2. It's a little trick that you can keep in mind, and it might be able to help for rationalizing by root 2. Okay, we're going to go ahead and do the second side of this page, which is these ones. So, number 12. Use the Pythagorean triples to find missing lengths of sides below. So for the first one, you should have gotten an answer of 54. How could you find out that it's 54? Well, there's two different ways. You can do the Pythagorean Theorem, and solve and get the answer as 54. Otherwise, you want to look for triples. You really do want to look for triples, as it does save you some time. Is there a Pythagorean triple that goes into these numbers? So our only options that I want to consider, at least for right now, is it a 3, 4, 5? Is it a 3, 4, 5? Is it a 5, 12, 13? Or is it any of the other ones like 7, 24, 25? I'll tell you right now, this one's not going to show up right now, but does 3, 4, 5 possibly go into these bigger numbers? No, those aren't going to go in as a scale factor. But 5, 12, 13, I know these numbers go in really well. Watch this. If I take the numbers 5, 12, 13, and I multiply them by, let's see, to get from 5 to 20, I need to multiply by 4. To get from 12 to 48, I need to multiply by 4. So to get to the hypotenuse, I need to multiply that by 4. So I'll get 20, 48, 54. All because we know that there's a 5, 12, 13 that exists, and we have a scale factor of 4. Final answer, 54. Okay, number 13. Is there a Pythagorean triple that goes into 600 and 100? Well, yes, absolutely. It's going to be a 3, 4, 5 multiplied by 200. It's a scale factor of 200. What that gives us is 600, 800, and 1,000. Notice how these sides match up. So what's the missing side? Yes, y is equal to 800. Now, if you want to skip this idea of Pythagorean triples, you can. You can always solve using the Pythagorean theorem. A squared plus b squared equals c squared. But if you look for triples, it could save you a lot of time. For example, number 14. If this is z, and we have a given sides of 5, 12, you can immediately see that the hypotenuse is 13. Why? Here's what you say. This is a 5, 12, 13 Pythagorean triple. And you're done. Otherwise, of course, you can show work using the Pythagorean theorem if you would like to. Here I will show it for you. 5 squared is 25. 12 squared is 144. Z we still don't know. Add these two numbers, you're going to get 169. Square root it. And you'll get the answer of 13. Would you rather do the Pythagorean theorem, or would you rather just say that this is a 5, 12, 13 Pythagorean triple and you're done? You get to decide. Okay, now we're going to move on to number 15, which is asking you to rewrite expressions in radical form and simplify if possible. Before I do that, I do want to present to you some notes, some ideas, some thoughts about fractional exponents. Basically, in the past, we've always been used to doing 5 squared, 10 cubed. But what if you ever took a number to a fraction? Okay, so here's a couple of notes. If you ever have a fraction, it's actually considered an nth root. So if I say like a number to the 1/5 power, that's called a 5th root, which you can write like that. If you have a 1/3 power, that's a cube root, which you can write like that. And if you have a 1/2 power, you can call it a square root, which looks like this, or more importantly, like that. You don't need to have a 2 there if it's a square root, because secretly, there's a little 2 there. Here's an example that I give to you. It's a 9 to the 1/2 power. If you know that 1/2 is the square root, then you can write it like this. 9 to the 1/2 is the square root of 9. The square root of 9 is 3, and you're done. What about 27 to the 1/3? We know 27 to the 1/3 is a cube root of 27. What is the cube root of 27? Also 3, and you're done. So is it possible to do fractions as exponents? Absolutely. Sometimes the fractions do get a little bit more complicated. For example, if I had 31 to the 5/2 power, or 4/3, or 1/3, 2/3, you know, these questions can get more complicated, and that's why we have this general rule, which allows us to rewrite fractions as radicals. So what I'm going to show you is a couple of examples to prove that basically when you have a fraction, the numerator is going to go over here, and the denominator is going to go as the nth root. Just like this one, right? The n is the number that goes in the root. It's the nth root. So here the n is going in the same place. Try not to mix them up. You don't want to switch the order of m and n, because if you switch them up, you're going to get the wrong answer. Okay. Here's another way to write it, and there's a benefit to writing it this way as well. And I will show you a couple of examples why. So our first example is going to be 27 to the 1/3. That can be rewritten as 27. The 3 goes here, and the 1 goes here. Well, what's the cube root of 27? 3. Done. Just like this. We did it before here. Now, a little bit more complicated is if you have the 27 to the 2/3 power. So here's one way to do it. You write the 3 in the same place. You write the 2 in the inside here. Now, let's see what 27 squared is. 27 squared.
The answer is 729.
We get the cube root of 729. That's if we want to do 7 squared or 27 squared first. What's the cube root of 729?
That would be 9.
9. Okay. Here's another way to do this. If I write the 27 to the 2/3 power as 27, but this time I write the 2 on the outside, what this means, and it's following this rule right here. What this means is I can take the cube root of 27 instead of taking the cube root of a huge number. The cube root of 27 is going to be 3. And if I take that number and square it, I will also get the same answer of 9. An additional way to do this is going to be to rewrite 2/3 as 1/3 times 2. What's 27 to the 1/3 power, right? It's going to be the cube root of 27, which is 3, and 3 squared equals 9. You'll see that there's multiple ways to do this, and that's why I do want to show you these 2 additional examples. Instead of 1/25 to the 4/3 power, I'm going to write this as 1/25 to the 1/3 power to the 4th power, because 4 times 1/3 is 4/3. Now, what's the cube root of 125? Cube root of 125.
The answer is 5.
Okay, and you take that and you multiply or do that to the 4th power. That's going to give you your answer of 625. 5 to the 4th power is 625. Now apply the same idea. How do you rewrite this one? That's going to be 31 to the 1/2 power, and that to the 5th. Well, how do we rewrite this? We write it as square root of 31, and we multiply that to the 5th power. This one is a little bit weird because we can't take the square root of 31, but we could rewrite this as 31, where the 5th on the inside. So now, what's 31?
Okay.
What's 31 to the 5th power?
The answer is 28,629,151.
So 28,629,151. Would you rather leave your answer like this or like this? It depends on your teacher, but I'm pretty sure that you can't take the square root of this number. Let's try it though. What is the square root of 200? Let's try it. Let's see what this number is. What's the square root of 28,629,151?
The answer is approximately 5,350.6215.
So that means we can't simplify. We have to leave it like that. Now let's take these ideas, these notes that we saw here, and let's apply it to the problems that we have right here. And I have to do this relatively quickly. For letter A, it's going to be, how do we rewrite this? So I'm going to rewrite this as 16. The 5 goes here, the 4 goes here. Now ask yourself, can we take the 4th root of 16? Let's try. What's the 4th root of 16?
It's 2.
It's 2. And if we take 2 to the 5th power, we're going to get 2 times 2 times 2 times 2 times 2, which is 32. Okay. Next problem, letter B. It's asking us to rewrite it, so we're going to have to write the -8. We have to write the 2 here and the 3 here. Remember, the 2 can go outside or inside. It doesn't matter. But what I'm going to do is I'm going to take the cube root of -8. What's the cube root of -8?
The answer is -2.
And what I'm going to do is I'm going to square that number. So -2 squared is +4. Letter C, it's asking us to rewrite it. So this time I'm going to rewrite the 6 square. The 2 goes here, the 3 goes here. But since I know I can't take the square root of 6, I'm going to write the 3 on the inside. What that allows us to do is it allows us to do 6 cubed. What is 6 cubed?
It's 216.
And it asks us to write the square root of 216. What's the square root of 216?
It's approximately 14.6969.
This means that we can't take the square root of this number, but I could simplify the square root of 216. I'm going to rewrite this as 36 times 6. 216 divided by 36.
The answer is 6.
We know that 36 goes in, and what I can do is I can separate these and get my answer of 6 root 6. That's the most simplified that I can get. Now problem letter D is asking us to simplify this one, but what I know is I can actually rewrite 3 over 6 as just simply 1 over 2. So yes, can I write this as 3, 6? Yes, I can, but this is not simplified. I will need to write it as 1/2. It's simplified. You can simplify 3 over 6 and get 1/2. So 1 goes here, 2 goes here. Now 2 questions. Is the 2 required for square root? No. We've never seen a square root with a 2 in it. And now is the 1 required? No. So our final answer is the x, or root x. Okay, next up is problem number 16. I'm going to rewrite this as a fractional exponent as it's requiring us to do. So what I need to do is write this as a fraction. Instead of it being cube root of 8 squared, I'm going to write this as 2 on top, 3 here. That's simply applying the rules that we learned right here. You can rewrite the numbers as fractions. Now, I need to simplify this, so I'm going to apply a rule that I tried out earlier. What I'm going to do is I'm going to write this as 8 to the 1/3 power squared. Because 1/3 times 2 is 2/3. So 8 to the 1/3, you can even try it in your calculator if you want to. 8 to the 1/3 power, just use parentheses. you're going to get the answer of 2. And 2 squared is 4. So that's how we got the answer of 4. Number 16 asks us to rewrite it only. So we have to write this as x to the 7/4. Remembering the 7 goes on top, and the number, which is the 4th root here, needs to go as a 7/4. Okay, number 16c. There is a secret 1 here. There's a secret 2 here because it's a square root. So I could write this as 1,000 to the 1/2 power. Now, these problems do get a little tricky sometimes, and that's why it requires practice. Can I rewrite 1,000 as any power? And the answer is yes. I can write this as 10 to the 3rd power. So what this allows us to do is write it as 10 to the 3rd power to the 1/2 power, which is 10 to the 3/2 power. That's as simple as it gets. It's not very simple to understand, but it's in simplest form. Okay. Next problem is going to rewrite this as 25 to the 1/5 power, since it's a 5th root. There is a secret little 1 there. So is it possible to simplify this any further? The answer is yes. Can I write this 25 as a power of another number? 5 squared. This is 5 squared to the 1/5 power, which is going to allow us the answer of 5 to the 2/5 power, and that's in simplest form. Now number 17. Number 17 is involving a lot of simplifying radicals and also some exponents. So let's go ahead and complete number 17, A through F. For this one, I want to combine the 4 and 5. I can just rewrite it. 4 times 5, and then group these two together as well. Root 6 times root 27. What that gives us is 4 times 5, we know we can combine those two together as 20. And we can combine these two under one square root symbol as well. So 6 times 27. 6 times 27. 162. Now, I need to look at the list of squares. Is there any list of squares that goes, or any number that goes into 162? So here's the list of squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Is there any number here that does go into 162? Right, the biggest number that goes in is going to be 81. So I'm going to rewrite this as 20 times root 81 times 2. What this allows me to do is I can separate those square root symbols now, and I'm going to get 20 times 9 times root 2. 20 times 9 is 180. So my final answer is 180 root 2. Now, letter B, there's no way you can combine these two currently, because it's like saying, what's apple plus 5 cats? Like, you can't really add those two together, but there's a trick to make them both apples, or both the same thing. Watch this. Let's simplify both of these square roots and get a simpler form of them. So again, we're going to revert to that list of numbers. Is there any number that goes into 12? The number that goes into 12 is going to be 4. 4 times 3. Now, I'm going to also simplify 27. What's the number that goes into 27? It's going to be 9. So I can write that as 9 times 3. My next step is to separate these just to show all my work. I'm going to write this as root 4 times root 3 plus 5 times root 9 times root 3. All I did was separate the square roots. Now root 4 is 2, because that's the perfect square. It's on the list. 2 root 3. Plus, and root 9 is going to be 3. So this is what we get. Now if we simplify this a little further, we're going to get 2 root 3 plus 15 root 3. This is like saying 2 apples, or should I say something different? It's like saying 2 nuggets plus 15 nuggets. 2 nuggets plus 15 nuggets is going to be 18 nuggets. Oh, I messed that up, right? 2 nuggets plus 15 nuggets is actually 17 nuggets. So 17 root 3. So 2 root 3 plus 15 root 3 is 17 root 3. Okay, next question, number 17. I'm going to rationalize the denominator. I'm going to multiply both sides by root, or not both sides. I'm going to multiply by 5 root 3 over root 3. Essentially, just whatever's in the denominator, I want to multiply that to both sides. What that gives me is I'm going to get on the top, or the numerator, I'm going to get 15 root 3. And in the denominator, I'm going to get 5 root 3 times 5 root 3. Which is 25 times 3. Now what I get is 15 root 3 over 75, which can be simplified to, well, 15 goes into 75 5 times. So root 3 over 5 is my simpler answer. Letter D, I'm going to multiply by root 20 over root 20. What that gives me is 2 root 3 root 20 over 20. Can I simplify this? Yes. First of all, 2 goes into both those numbers. I can divide both by 2. And I'll get 1 over 10. And then I'll also get root 3 times root 20, which is root 60. You might be tempted to leave your like this, but can I simplify root 60? What number here goes into 60? Perfectly. The only number that goes into 60 is going to be 4. So 4 times 15 over 10. Which gives me root 4 is 2. 2 root 15 over 10. Can I simplify that? Right, 2 over 10 is going to be the same as 1/5. So root 15 over 5. Yes, these are complicated, but with practice you're going to get really good at it. Okay, letter E, 17E, is going to be, let's rewrite 17E as a square root. But as a matter of fact, this is going to be a 4th root. So 81. The negative 3 goes here, the 4 goes here. Let's see if it's possible to take the 4th root of 81. So I can just go ahead and try this. 81 to the 1/4 power. Use parentheses. That's going to be 3. And 3 to the negative 3rd power, that's the same as 1 over 3 to the 3rd power, which is 1 over 27. Negative exponents go to the denominators. Same thing with letter F. We have negative exponents. We have to move them to the numerator and move them to the denominator. So this negative is going to go down. This negative is going to go up. And this negative is going to go down. First of all, let's rewrite it. So this a goes down. What's left is just a b cubed, right? Or let's check. Oh no, this a is going up, right? So we're going to get a to the 4th power. It's now positive. B cubed. And now what's left on the bottom? Let's see. 18. This one went down. A to the 2nd power. B to the 4th is still there. C to the 3rd power is still there. But now we also have a negative 1 turning into a positive 1. So it's going to be a C to the 1st power as well. So let's simplify this. Six over 18 is 1/3. And if I do 4 minus 2, that's going to give me a to the second power. 3 minus 4 is going to give me 1 on the bottom. And then c to the fourth power. You might be asking, is this the easiest way to do this? So I'm going to show one last way to do this problem. So I'm going to write this in a different color, just a pencil at least. That's all I have right now. So here's an OR. Here's your second option. 6 over 18 is 1/3. Now just do this. For a, since this is division, I'm going to go ahead and use subtraction for laws of exponents. So -2 minus -4. B is going to be b cubed minus 4. And for C, it's going to be -1 minus 3. What this allows me to do is just use subtraction instead of thinking about division and moving numbers around. So what I'm going to be left with is 1/3. -2 plus 4 is 2. 3 minus 4 is -1. And for C, -1 minus 3 is -4. So if it's positive, it's on the top. If it's negative, it's going to be on the bottom. So we have a squared on the top. We have the 3 on the bottom now. B is negative, so it's going to be on the denominator as positive. And C is negative, so it's going to be on the denominator as positive. And that's another way to get to our answer. I hope this helped, and I wish you all luck in studying for your quiz. Have a good weekend, everybody.